And welcome back, students. Today we are going to get started with talk about encapsulation and inheritance. So to start off this lesson, first we need to talk about the pitfalls of private instance variables and methods. So getting started, an object of the class hourly employee inherits, among other things, an instance variable called name from the class employee. For example, the following would set the value of the instance variable name of the hourly employee object Joe to Josephine. Joe.setName, Josephine. All right, so our pitfall is the use of private instance variables from the base class. So we need to be a bit careful about how we manipulate inherited instance variables such as name. The instance variable name of the class hourly employee was inherited from the class employee, but the instance variable name is a private instance variable in the definition of the class employee. That means that the name can only be accessed by name within the definition of a method of the class employee. Hourly employee has no ability to directly call that instance variable. An instance variable, or method for that matter, that is private in a base class is not accessible by name in the definition of a method or any other class, not even in a method definition of a derived class. So, for example, let's actually put some connotation here. Notice the following method definition taken from the definition of the class hourly employee. Public string, toString, return get name plus get hire date, toString plus $, wage rate plus per hour for hours. All right. So if you look in here, you have wage rate and you have hours, which of course belong to hourly employee. So you might need, if you wonder why we need the methods get name and get hire date, right? You might be tempted to rewrite it as follows: name plus hire date toString, wage rate, and hours. Right? Pretty much omitting the get name and get hire date. However, as the comment indicated in that previous line of code, this is not going to work. The instance variables name and hire date are private instance variables in the class employee, and although a derived class such as an hourly employee inherits those instance variables so it can use them, it cannot access them directly. Right? So even though yes, you can use them, you can't access them in an instant way. So instead, we have to use some public methods to access the instance variable name or hire date, as we did in hourly employee. In the definition of a derived class, you cannot mention a private inherit instance variable by name. You must instead use the public accessor or mutator methods, such as getName or setName, that are defined within the base class. The fact that a private instance variable of a base class cannot be accessed in the definition of a method of a derived class often seems wrong to people. They're like, well, I should just be able to call that whenever. So, for example, if you're an hourly employee, you want to change your name, it always says, sorry, name is a private instance variable class employee. So if you're an hourly employee, you're also an employee. However, in Java, this is also true. An object of the class hourly employee is also an object of the class employee. However, the laws that are in place, the rules that Java uses on the use of private instance variables and methods must work as described. Otherwise, they would be compromised because they really wouldn't function in their private manner anymore. Right? So if private instance variables of a class are accessible in the method definitions of a derived class, then any time you want to access a private instance variable, you would simply create a derived class and access it in a method of that class, which would mean that all private instance variables would be accessible to anybody who just wants to really kind of put a little bit extra effort in. Right? Remember, the whole point of private instance variables and private methods is so that the person using the program doesn't have to know what they are. Right? Public ones, yes, you want them to be able to call the public methods, but the private ones, you don't need them to have access to. Now, this scenario obviously illustrates a small problem, but the big problem is that unintentional error is not intentional subversion. Right? So if private instance variables of a class were accessible in a method definitions of a derived class, then the instance variables might be changed by mistake or in inappropriate ways. So this is part of the reason why we want to make sure that we're not falling into this trap here. Remember that accessor and mutator methods can guard against inappropriate changes to instance variables. Now, there is a slight way around this restriction that we're going to discuss in an upcoming lesson. Right? Now, let's really quickly talk about those private methods. We've mostly just been discussing private instance variables, but an instance variable or method that is private within a base class is not directly accessible outside the definition of the base class, not even in a method definition for a derived class. The private methods of the base class are just like the private variables in terms of not being directly available. So whether it's a method or a variable, if it's private, can't access it. But in the case of methods, the restriction is much more dramatic. A private instance variable can be accessed indirectly via a accessor or a mutator methods. Because remember, a lot of times those private methods end up becoming helping methods. All right, and a private method, as you know, is simply not available for the end user. It's private. It is just if the private method were not inherited. Right, so we don't really worry about private methods being able to be called by the derived class. The derived class really can only call the public methods. So in one sense, private methods in the base class may be indirectly available in the derived class. If a private method is used in the definition of a public method of the base class, then the public method can be invoked in the derived class, or any other class for that matter, so the private method can be indirectly invoked. So let's say the public method invokes, as part of its process, a private method. Well, it's not going to not be able to access that private method if you're calling it from the derived class. So it's still going to have access to it. It's just that you won't be able to call it or do anything with it from the derived class. All right, and that's going to put a quick wrap on things for today, folks. So until the next time.